Alright, in this video we are going to solve a system of equations, and we're going to do that with a specific method today, and that is going to be the substitution method. There are other methods which we'll discuss in later videos, but today we're going to focus on substitution method. So a system of equations is where I have two or more equations where I have two or more variables, right? And what I want to do is I want to find out what x and y will make both of these equations true, and that's what's called solving the system, all right? So we're going to start off by using the substitution method, and we're going to look right here. We can see I have a y that is by itself, right? So it's very easy. I can just subtract 2x from both sides. Now I end up getting a 0 here, so our new equation will be written as y equals 6 minus 2x. And so from here, we're going to use the substitution part. I know y is equal to 6 minus 2x, which is what I'm going to plug in right there to that equation. And when I do that, that looks like this. I have 3x minus 3 times 6 minus 2x equals 9. And all I have done is replace the y with what I know y is equal to, which is 6 minus 2x. And from here, I'm just going to distribute and solve for x. So then that's going to give me negative 18 plus 6x equals 9. I'm going to collect like terms together. That's going to give me 9x. I'm going to add 18 to both sides, and that is going to give me 27. And then I'm going to divide by 9. That becomes a 1. X is equal to 3. Okay? So now what I know is, all right, so now I know x is equal to 3. So I'm going to take that back, and I'm going to plug it back into this equation. And it really doesn't matter if you plug it into the first one or the second one. So now to find y, I'm going to say 2 times 3 plus y equals 6. So I know 6 plus y equals 6. And if I subtract 6 from both sides, I get a 0. So I know y equals 0. So now I know x is 3, I know y is 0. So we're going to write that in coordinate form here and have the coordinates of y equals 0 as being the solution to that system of equations. All right, so when x is 3 and y is 0, both of these equations will be true. All right, so now here's another example. I want you to pause the video, try it on your own, and we'll come back and check it together. All right, so now that you've had a chance to try this on your own, I'm going to notice that the x and the y are both by themselves, so it doesn't matter if you subtract the x over or the y over. I prefer to subtract the x over to both sides, right? So that gives me a 0 over there. So what that new equation looks like is y equals 4 minus x. I'm then going to take the 4 minus x, I'm going to plug it into my y right here, and that is going to look like this, 5x plus 2 times 4 minus x equals 11. So if I distribute the 2, I get 8 minus 2x plus 5x equals 11. Collect like terms and get that to be 3x. Subtract 8. So that's a 0 equals 3. Divide by 3. That's a 1. What I know now is x equals to 1. So now I'm going to choose either equation. I'm going to pick the simpler one right here, right? So I know x is equal to 1, which I'm going to plug in right there, right? It's a super simple equation to plug it into. So I know 1 plus y equals 4. Subtract 1 from both sides. That's a 0. And y equals 3. And if I write it in coordinate form, I get 1, 3 as my coordinate. Okay? And that is using the substitution method. So let me give you a little hint on when to use the substitution method, because no matter what system you get, you can use any of the methods that we're going to talk about. However, sometimes substitution is easier than elimination, which we'll talk about. Sometimes elimination is easier. But in this case, if you'll notice, I have a variable that has no constant with it. So all I have to do is move that 2x over, and it becomes a real easy substitution problem, right? Same thing down here. I have two variables that don't have a constant. So again, it makes it real easy to solve for any of those given variables and easily plug it in, okay? So whenever you see something like that, substitution will always be a good choice for you to use there, all right? I hope this video helps, and we'll see you in the next one.